So hello everyone, thanks for watching this video. Today I'm going to briefly talk to you about the research that we are conducting at CUHK. The research topic is about high performance wireless for industrial Internet of Things. So this is Professor Chen. I'm leading the wireless IoT system group at the Department of Information Engineering, the Chinese University of Hong Kong. So if you have any question after watching this video, feel free to contact me by this email. So the first question is, what is industrial IoT? Because I think most of you know what is IoT. IoT is basically want to use certain technology to connect the things. For example, the air conditioner, the cars, and any appliance in your home to the internet, such that you can control it when even you are not at home. This is the basic thing of IoT. But industrial IoT is a sub-area of IoT. It's basically using IoT in various industry verticals. This is also called industrial internet. In US, probably this one is more popular. So industrial IoT application will include the robotics, industrial manufacturing, factory manufacturing, smart grid, smart utility. This is mainly for smart building things, smart city, smart car, smart communication. This sort of things are all referred to industrial IoT. But industrial IoT is going to be big. And this is predicted by a company that said that by 2025, the industrial IoT will touch 43% of the global economy. It will affect the agriculture, transportation, healthcare, and manufacturing, and a lot of other industries. And as we know that today's internet, we call it consumer internet. This value is already very, very big. But as predicted in this report, it's saying that by 2025, the value of industrial IoT will be more than twice of the consumer IoT. We can see that this is going to be a very big thing. So we are going to contribute this by designing high performance wireless. But when we mention about wireless, actually wireless is part of our daily lives. We use, you use your mobile phone and almost every day, you use Wi-Fi almost every day. These are very representative wireless communication technology that is in our daily lives. But when we see the industrial world, actually wireless is not popular. Why I said that? This is a very recent market share survey by a leading company called HMS based in Europe. And it said that there are different technology using, communication technology in the industrial world. And you see that field bus, industrial Ethernet, both are wide communication technology, and wireless is here. So wireless is only occupies 6 market share. Imagine that. When I see this value, I was shocked, because wireless is almost replace everything in our replace most of the cables in our daily life, but the cables is still popular in the industrial world. Then I start to ask the question, why the penetration of wireless in industrial world is so small? So I guess some reason why wireless is rarely used in the industrial world. This is because today's wireless has been developed for human-to-human communication. Remember the cellular communication or the Wi-Fi communication, they are both developed for human-to-human communication. But IoT application require very reliable and immediate delivery of data containing the measurement or control command between machines. So the the required delivery latency means how fast it's going to be delivered, and reliability is how reliable the data need to be reliable, are several orders of magnitude beyond today's wireless network at the chip can achieve. Basically, the key reason is the wireless is not good enough to support the requirement of communication requirement in the industrial world. So this gives us a big chance. So we are developing a clean slate, high performance wireless technology with very, very low latency. Means if you send the data is going very fast and receive very reliably at the receiver side. This will going to be support the mobility in various industrial verticals. Next, I'm going to give you two simple applications. The first application is called cross-belt sorter. This can be used very widely in the automated logistics. You can see that there are some these cars moving in this direction, and each of these one is basically a small car. This small car, you see that there is a belt on it. This belt actually can move in this direction or this direction. You will see that on each car there will be a parcel on it. When the parcel arrives its destination, then the car will push it to the corresponding destination. This has been widely used to sort the parcels in smart logistics. So the communication, you did not see it actually. The communication used to support this one. It's actually a Wi-Fi based technology. You will see that you will have a coax cable that can radiate wireless signal to these small cars. This is one car, this is another car, this is. So when the car is moving, when it has a parcel on it, and when it's read the barcode of the parcel and know where it should be unloaded from the car. And then when it's when it's going to arrive at the destination, it will send a command to the controller. This is the controller. The controller will give a command back and say, okay, unload the packet. This need to be very fast, otherwise you will miss at the destination and go to a wrong destination. So this is one of the why we use wireless here, because this car moving, you cannot use cables. If you use cables, your cable will suffer from issue when you use it in a long term. So this is why we need to use wireless. This is one application. The other application I'm going to share is this one. This one is actually a high precision cooperation between the manipulator, is this basically this robotic arm, and this mobile robot. This mobile robot is another way of sorting these puzzles. I will show you a short video later. So you will see that these puzzles are moving in this belt, and this robotic arm need to pick these puzzles and place on this. We call this mobile robot. We normally call the automated guided vehicle. So then this machine will move these puzzles. These robots will move these puzzles to the destination it's going to be. So you see that if you want this robotic arm to place a puzzle on this box, on this AGV, the AGV need to be well synchronized with this one. Otherwise, it may miss this robotic arm may miss one of the AGV. Today, the solution is not very, very efficient, because the AGV need to stop here and wait until this robotic arm pick up a puzzle and place on, and then it's move away. So it's come here, stop, and wait. Okay, stop and wait. But this is not going to be efficient. So imaginary that if we can have a very good performance of wireless communication, that can have a synchronous, high synchronous synchrony between this robotic arm and this AGV. In that case, when the AGV is moving, we we can place the puzzle on it. Then in that case, there is no need for the stop and wait. Then the whole system throughput will be increased a lot. Okay. So next, I'm going to give you a short YouTube video to see the problems in the world in real system. Okay, let me show you the video here. So this is basically an automated warehouse in mainland China. It's made by JD.com. And you see that the problem I just mentioned to you, it's real problem. Okay, let's watch the video. You see that this kind of component will come out, and robotic arm is picked, and the camera read it, and it's placing the corresponding this box, and then it will go to the relative box. And this is a way how you can pick this one out. So everything is automated. Actually, in this type of things, you also use wireless because your box are moving. Actually, there is a AGVs. This is AGVs. You see that when this one arrives here, and another robotic arm pick it up and read it and place it on another belt. Then it start to packing it. This basically putting the corresponding one in a box, pack it in a box, and then you see it will be automatically packing, and then it will be placed on information on that. And you see this small AGV. This is basically the AGV. Then this robotic arm need to place. You see this AGV need to wait before it's move out. So actually this is a problem that we are going to solve. Then the AGV will be placed the puzzles on the corresponding hole. The hole actually behind this hole is a bag that collect the puzzles that go into the same destinations. And this is basically roughly what I'm going to share. So so then it's go to the trucks and move away. This is basically what I'm going to share to you. So this is the end of the talk. So again, in case you have any question, feel free to email me while using this email address. Thanks for your attention.